Welcome to our help videos on 3B6 laboratory, the Build an Atom laboratory, where we're getting comfortable with atomic number and mass number. In our first part of the lab, we are asked to build the 3 hydrogen isotopes. And the first one they ask us to build is hydrogen 1. When you write hydrogen 1 in this format, where you write the name or symbol, hyphen followed by a number, you're using what's called hyphen notation, and the number they give you is the mass number. When they give you the mass number, and when they use hyphen notation, they are assuming you have a periodic table to look up hydrogen's atomic number. They're giving you the mass number, but you need a periodic table to look up the atomic number. So we'll take a look at a periodic table. Here we go. Here's a periodic table. There's hydrogen's atomic number in the upper left-hand corner on this table. So hydrogen has an atomic number of 1. That means hydrogen has 1 proton. If hydrogen has 1 proton and its mass number is 1, mass number, if you recall, is the total number of particles in the nucleus. It's the total number of protons and neutrons in the nucleus. And the protons and neutrons, any particle in the nucleus, is called a nucleon. So mass number gives you the nucleons, or that's the same as saying the total protons and neutrons. So if hydrogen has an atomic number of 1, that means there's a proton in the nucleus, and a mass number of 1, that means there's 1 total particle in the nucleus. That tells us that hydrogen 1 only has a proton in the nucleus. So let's take a look at the Atom Builder program right here. We know the hydrogen has an atomic number of 1, which is telling us the protons. So we put the 1 proton in there. You can see we have 1 proton in the nucleus. 1 proton in the nucleus is hydrogen, as it's been highlighted here. Now, if we have 1 particle in the nucleus, our mass number should also be 1, and it is. So this is what the nucleus looks like for protium. Protium is hydrogen 1. Pro means like the simplest form of something. However, our ion is a positive ion because we have 1 proton. Our net charge here is +1. We have 1, or really 1 plus. On this particular program, they write it as +1, but the true convention in chemistry is to write number followed by charge, so it really should be 1 plus. We have 1 proton. The only way we can counter that 1 positive charge, that 1 proton, is to add a negative particle, an electron. I'm going to try to put it in the nucleus. It won't go in the nucleus because electrons are not found in the nucleus. They are found orbiting the nucleus in 3-dimensional orbits. On this particular program, they're making them look like they're 2-dimensional, flat, planar orbits, sort of like planets going around the nucleus, which would be like the sun. But actually they're 3-dimensional. As this electron's moving, it's going up and down as it's going side to side, giving it a 3-dimensional orbit, which would be called an electron cloud. When you look at all the 3-dimensional orbits of the electrons buzzing around the nucleus, it looks like a cloud. So anyway, we added the 1 negative particle. It balances out the 1 positive particle. Here they're showing for every positive we have a negative, so the net charge is now 0. So we have our model of hydrogen 1 called protium. 1 proton, 1 electron. So what did we decide our mass number was? It is 1. So down here we put in the mass number. That's the mass number right here. There's 1 total particle in the nucleus. Our atomic number is also 1. We looked it up on the periodic table. In the upper left-hand corner on the periodic table, they had the 1. However, here we are writing it in a nuclear symbol format. In nuclear symbol format, the mass number goes in the upper left, the atomic number goes in the lower left, and if there's a charge on the ion, charge on the atom making an ion, we can add it right there. So that's our nuclear symbol format for hydrogen. Now they're asking, is it stable or unstable? Is having 1 proton in the nucleus stable or unstable? We come down here and click on the stable unstable button, and we would see that it is stable. So that takes care of hydrogen 1. We're now going to move on to hydrogen 2. Hydrogen 2. 2, the prefix which means 2 is deuterium. So hydrogen 2 is often called deuterium. The mass number for hydrogen 2 is 2, so now there's 2 total particles in the nucleus. We cannot change the number of protons in the nucleus, though. The nucleus has protons and neutrons. We can't add a proton to bring our mass number to 2. If I do add a proton, the mass number does go up to 2. You can see it right here. However, we no longer have hydrogen. When we added that proton, we now have 2 protons. The element with 2 protons in the nucleus is helium. If you look on the periodic table, any atom with 2 protons in the nucleus is helium. So we can't change. As we're changing the mass number, we can't add protons to increase the mass number because that changes the element we're working with. So I've got to pull that proton back out of there. And now I'm going to add a neutron to the nucleus. That brought the mass number to 2. I've just done deuterium. Now, do I need to add another electron to balance out that neutron? Well, neutrons are neutral, so the charge has not changed. When I added this neutron, watch right here in this box. The net charge does not change as we are adding neutrons. It doesn't change. Neutrons are neutral. So the only time I would need to add electrons to keep it balanced is if I'm adding protons, which would in fact change what element we have. So here is deuterium. Let's take a look and see what it looks like. 1 proton, 1 neutron. That's 2 total particles in the nucleus. That means the mass number is 2. I have 2 nucleons in the nucleus. The protons and neutrons are called nucleons. Any particle in the nucleus is a nucleon. And there is my 1 electron balancing out the proton. So my mass number, 1, 2, 2 particles. There's my mass number. Of the 2 particles in the nucleus, 1 of them is a proton. The proton's red, so I colored my atomic number down here red. There we go. Now, did I change the stability by adding a neutron? Did adding a neutron change the stability? Nope, it's still stable. Still stable. Now, the next one they're asking us to build is tritium. So, protium is 1 proton. Deuterium is 1 proton, 1 neutron. Tritium is going to have to be 1 proton and 2 neutrons. Again, we can't add protons to increase the mass number and have it be the same element. So I'm going to add another neutron on my atomic builder. Again, 1 proton, 1 neutron was deuterium. If I'm like, oh, I'm going to fix the mass number and make it go to 3. Well, the mass number did go to 3 when I added the proton, but now I have helium. So I can't add a proton to make it hydrogen 3. I have to add a neutron. The mass number went up to hydrogen 3. So I now have 3 particles in the nucleus. That's tritium. The particle I added was a neutron, so another electron is not required. I would not need to add another electron. So now how many particles do I have in the nucleus? 1, 2, 3. There they are. Now, how many electrons do I have? Still 1. So, or how many protons do I have? Excuse me. Still 1. 1 proton, so my atomic number remains 1. And if it wasn't 1, then I couldn't have the symbol H here for hydrogen. Is it stable now? When we added this additional neutron, bringing the total to 2, look what happened to the stability. It was stable with 1 proton, 1 neutron. But adding this next neutron made it unstable, which means that this nucleus is not wanting to stay together. It's going to want to change over time. And why is that? Well, with small atoms, if we get too many neutrons in the nucleus, it makes that nucleus unbalanced or unstable. So this nucleus would have to change. When a nucleus changes, it is a nuclear reaction, not a chemical reaction. So what happened to the stability of the nucleus when the ratio of neutrons and protons was increased to 2 neutrons per proton? Well, with smaller atoms, and the ratios of neutrons to protons depends on the size of the atom. The bigger the nucleus, the more neutrons you need to buffer the protons to make it stable. The protons are all positive, pushing apart. They try to repel each other inside the nucleus. When you put the neutrons in there, they act as a buffer between the protons to keep them from trying to push apart. But when we only have one proton in hydrogen, we only needed one neutron maximum. Actually, we were stable with no neutrons, because when you only have one proton, they're not trying to push apart. You need two protons to push apart. So adding that additional neutron made it unstable. We're now looking at part 2 of the lab, where we're going to take a look at the two ions that hydrogen forms. Hydrogen is a rare element that can form a positive ion, the hydrogen ion, which is a cation, and it can also form a negative ion, which we call an anion, and that would be hydride. When you have a negative ion, you can recognize the name because it'll have an IDE on the end. Anions generally end in IDE when it's a monoatomic ion. When it is a positive ion, it is allowed to keep its name. So the first one they're wanting us to build is H+. They want us to build H+. How do we do H+? It's very easy to build H+. Let's reset this. We know they want us to build the one with one particle in the nucleus. They wanted a mass number of 1, as we saw right here. They wanted a mass number of 1, and they wanted that mass number to be a proton. So here we go. There's our proton. Our mass number is 1. Oh my gosh, we have a positive ion. That is the hydrogen ion. How did it really get there? Well, hydrogen started with 1 electron. And in a chemical reaction, another element came along and ripped hydrogen's electron off, leaving a positive ion. When you have 1 proton with no electron to offset it, it's 1+. Why does that happen? Because other elements, other atoms want electrons. There are atoms that want electrons. And hydrogen is one element that they can rip its electron off. So here's the nuclear symbol, mass number 1, proton is 1, H+ means there's no electrons. If I come down here, what are the total protons? There's my total protons, atomic number is 1. How many electrons did I have in this? There were 0. So I put 0 electrons on this line. 1 minus 0 is 1, and it's positive 1. So I put the positive on the end. 1 minus 0 is a positive 1. But in correct convention of chemistry, the positive sign follows the symbol. The next thing I want us to do is to show why the mass number was 1. Well, we saw that there were 0 neutrons in our nucleus. There were no neutrons there, and there was 1 proton there. 0 and 1 is 1 for the mass number. Now we're going to take a look at the hydride ion. The hydride ion is an anion. It's going to still be a mass number of 1, meaning 1 particle in the nucleus, atomic number of 1, meaning that the 1 particle in the nucleus is a proton, but now they want it to be H-. So we go back to our atom builder. There's my 1 particle in the nucleus, mass number is 1. And now I'm going to add 1 electron on there. So now I have 1 electron on this atom. Boom. It's balanced, but they want -1. So I put another electron on there. To get it to be -1, I need 1 more negative, then I have positives. So this positive is bounced off by this negative, but that second electron I added doesn't have a proton to balance it. It's still hydrogen. It's still hydrogen. I didn't change the number of protons, but this is the H- ion. Now hydrogen has 2 electrons. What element has 2 electrons? The answer is helium. If you look on the periodic table, helium has an atomic number of 2, which means it starts with 2 protons. It has 2 electrons when it starts. And helium is in this family to the right, the noble gas family. The noble gas family is inert. They are chemically stable. They will not react. Why? They do not need any more electrons. So when hydrogen gets 1 electron, it ends up chemically stable like the noble gas family, specifically like helium. This is good for hydrogen. So taking a look at what we have here, we know that we had, for the charge, we had 1 proton. Now we have 2 electrons. 1 positive minus 2 gives us a 1 minus. 1 minus 2 is -1, but remember the minus sign goes on the end. In the nucleus, we still had no neutrons. We had 1 proton for a mass number of 1. In our next video, we will answer the remaining questions on hydride ion.